So hello everyone, my name is Ritvik.
Hello everyone, I'm Casual and we are from Group 4. And today our topic is AI-driven intraday prediction system for Bank Nifty using LSTM. And these are our group members. Next, project overview. So basically, we have worked on intraday data set and uh, markets produce extremely noisy and fast moving data, and most people only see end of the summaries. In our project, we focused on predicting whether one the next 1 minute candle would close up or down. We approach this as an information processing problem rather than trading strategy, and that means the emphasis was on structuring, cleaning, modeling, serving, and explaining the data. We build up a complete pipeline that uses raw data into model engineering features into LSTM model and deploying it through fast API service, visualized it in Streamlit, and explained it using ChatGPT. This mirrors our workflow used by quantitative research teams in real institution. Next, why predicting the next 1 minute candle is hard. 1 minute prediction is one of the most hardest tasks in finance. Microstructure noise dominates at high frequency, which makes the direction at the 1 minute horizon almost random. Marketing regimes also shift continuously, and bid ask bounce and spread changes further distorts signals. Because of these challenges, the task is perfect for demonstrating the limitation of machine learning in finance, especially when only using OHLC data. Next, we worked on over 1 million rows of data set, which is Bank Nifty OHLC data from 2013 to 2024. And the target label was 1 if the next minute's close was higher and 0 if it is low. We cleaned timestamps, removed holidays and inactive periods, handling missing values, and ensured everything was in time order. This gave us a clean base for building predictive features. Next. To extract structures from noisy 1 minute bars, we engineered several meaningful features. These included log returns and the intrabar high-low range, two moving averages, and realized volatility measures. These features captured momentum, volatility, clustered, and short-term market behavior. We also formatted time correctly, removed inactive days, and scaled the data using only the training set to avoid uh, look ahead basis. Next. To prepare data for LSTM, we built sliding windows for 30 minutes each. Each window became one training sample, and the label was the next minute's direction. We used a stride of 3 to reduce the data set from over a million rows to around 62,000 only sequences. This structure turns raw time series into supervised learning inputs that LSTM can learn from. Next.
All right. So as spoken by Casual about about the project and summarizing the problem statement and the feature engineering aspect of our project, I will talk about the LSTM model design, like the LSTM model which we used. So our model had a two-layer LSTM built in using PyTorch. We had a configuration such as the hidden size was 64. We added a dropout layer of zero point 0.2, and for the activation layer we used sigmoid output for binary predictions. Additionally, we utilized Adam optimizer, and the loss function was binary cross entropy. So we trained our model for like 50 epochs based on the time based splits. So as you can see from the image, we have clearly utilized like 50 epochs for this project, and the overall text accuracy which we got was 50%, and the maximum validation accuracy was 50.35%. The test loss was 72.62%, and this helped in matching the academic findings that 1 minute direction is usually an unpredictable task, especially when it comes to intraday trading. So this really helps in confirming that real near random walk behavior at a microstructural level. Uh, so now I'll talk about the end-to-end system workflow which we utilize. So as spoken earlier, so we have taken Bank Nifty dataset from 11-year range. The dataset also included the dataset included like 1 million rows. Uh, and So what we had done is we have performed a feature engineering also uh, by you, and we have utilized LSTM model for training. The model exported with a scalar and a metadata. For further enhancing our project, we utilized Fast API backend for inference and hosting the project on a Streamlit dashboard for visualization. And to add much more complexity into our project, we had utilized OpenAI's GPT-4 API token, which helps in giving a proper explanation of the charts and of the outputs which we are getting. So, which makes it much more like trustable for the user. And as you can see, we have predicted the real-time prediction API. We have utilized Fast API Swagger UI for this task. So the endpoint over here is predict intraday LSTM, and as you can see, we have taken index to be 300, and we have executed this task. So, which makes it like beneficial for a user because they can input the index by themselves, and it reconstructs a 30-minute window, scales features using the saved standard scaler. And the deliverables from this UI is like it predicts a prediction probability, predicts also predicts the predicted direction and the window statistics as well. So yeah, so this is the output which we get when we press the execute button in the Fast API UI. So over here, as you can see, we get a list of things such as the end start price, end price, the change in price, average return, value return, and the index, and also the LLM explanation part, so which I was speaking earlier. So yeah, this is the Streamlit dashboard which we had built. So over here we have taken we have a prediction setting where we have set the index to 300, and we have applied get predictions, but we have pressed the get predictions button. So this is the result which we got. As you can see, this is the graph which demonstrates the last 30 minutes before this date and the time period, and this is the probability for it to go up, and it states that whether it will go, this part tells us whether it will go up or not. So what we have seen over here is we have an index selector, a 30 minutes price point, predictions, direction, and confidence, and obviously the natural language explanation using the GPT-4 like LLM which we had used. The important thing to consider over here is the probability, as you can see, is 51.5 in this case, and over here also we have the same probability. So this shows the great sync between the Streamlit dashboard and the Fast API backend. Now, this is the LLM explanation part which I showed earlier. So we get that also in the Streamlit dashboard. Now, this is the additional things which we get in the Streamlit dashboard. Like it shows the similar start price, end price, and everything. Other important aspects which were required in the intraday trading, as when we take into consideration the intraday trading. Uh, and this table also shows the underlying 30-minute window by taking these things into consideration. So so now it's important to understand what we had built or what these projects demonstrate. So for this project, we had taken deep learning struggles as at ultra short horizons. Uh, we have also taken into consideration high frequency OHLC data, that, and we have gotten a result that it is too noisy for a directional prediction. What and additionally, a complete and reproducible ML pipeline is essential for this in order to predict the intraday uh, predictions using Bank Nifty. So We have combined machine learning with backend service such as a fast API and natural language LLM explanation, which helps in mirroring the industry practice. Uh, this also helps in building an interpretability. It also helps in establishing that interpretability matters more than raw accuracy in the field of finance. So the difficulties encountered by us were like near zero signals in 1 minute OHLC data, non-stationary behavior over 11 years because a lot changes in stock market over a specific time range, and LLM sensitivity to window size. So like we had taken a specific window size in which the LSTM models were little unreliable, so we had to fix a clear balance towards that. And feature set lacked order book or the volume depth. Additionally, generalization remained limited, like the model generalization for us was like slightly like limited. Uh, Now this is the future scope, the changes which we would want to enhance in our project. So we would want to add a microstructure feature like order book imbalance, explore certain architectures like GRU, TCN, transformers, uh, transformers and deep LOB. So these are all like high level deep learning like architectures which we will utilize. So this will help in understanding the varying nuances present in the bank nifty data set. We will use a regime detection for stable performance and deploy with real-time streaming such as Kafka and Redis. So this will also help in keeping the memory, which can be beneficial when we have to build a like project using a long-term data set, which may be for like 10 to 20 years, and combine various LLM explanation with SHAP for hybrid interpretability. And yeah, so from this we can conclude that the project which we uh, we want to conclude by saying that we had built a complete ML pipeline for a high frequency finance data set, and the project demonstrated a practical constraint of LSTM on noisy data, and we created an explainable and interactive system. And this project also shows how modern quant teams process and communicate complex data. And this also helps in reinforcing importance of engineering, interpretability, and reproducibility. And yeah, that's all from our side. And these are the list of references. So uh, we have a GitHub repository, and in which this shows the project which we had built, and these are additional references which we utilized. And now I would just want to show you guys the the firstly the fast API Swagger backend which we had taken. So over here we have the get health function and the predict.
Ritik, actually, we cannot see the screen right now.
Okay, just a moment.
Okay.
I will just let me know if you can.
Okay.
Uh, why is it not sharing? Uh, Moment. I will share that screen. Can you see?
Um, yep, I can see.
Yeah, so as you can see over here, we have like two backend functions in the fast API Swagger UI interface. So which has a get health function. So which shows the status okay, which means the project is running. And over here we have like the predict intraday LSTM, which I was talking about earlier. So in this we can change the parameters just like how on our basis. And we have set it to 300. And when we execute it, then we get this as the response, which has all these details. And I will also like to show you Streamlit dashboard. So can you see the Bank Nifty LSTM screen?
Not yet.
Okay, just a moment. I'll just share it.
Okay.
Uh, mm, can you see that now?
Yep, I can see.
Yeah, so this is the screen. This is like the Streamlit dashboard, and we have taken the prediction settings again to 300 just to see whether we are on the right page. And
Yep.
again, as I spoke earlier, we have the same probability and the window pricing change, and these are all the other aspects. And it shows that a model is going, the direction is going up. And this is the graph in which we have taken the last 30 minutes before this 1st of Jan. 2013
13.
the time range, and it shows the model LLM natural language explanation over here, and very clearly with it, we have built it for educational purpose and demo only, and not for any investment or trading advice. And okay, this is the raw API response and the 30-minute underlying window data. So that's all from our side. Thank you so much for this
Thank you.
opportunity. Mm.